And we're back and better than ever, now starting 12.2 chemical calculations. In this particular section, we're going to introduce you to the idea of what's called the mole ratio. And the mole ratio is a powerful tool because it it allows you to change back and forth between the different species or different compounds in a chemical equation. Okay, so let's go ahead and scroll down just a little bit, give ourselves a little bit of room. We're still working with the production of ammonia. It's the same reaction that we used in 12.1, where you have 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of ammonia. So therefore, if I have 1 mole of N2, I'm going to produce 2 moles of ammonia. That's what the balanced equation says. Well, now what we want to show you is how to get that mole ratio that will change the N2 into NH3. And all you're looking at are the coefficients that are out in front of the molecules. As it turns out, you're going to produce 2 moles of NH3 from every 1 mole of N2. That is the mole ratio. And now if you notice, the moles of N2 on top divide out with moles of N2 on the bottom. You're left with moles of NH3, which is what you're trying to get into. And now you simply take the 1 times 2 divided by 1 gives you the 2 moles of NH3. Alright? Now if you want to make 2 moles of ammonia, alright, the question is, how many moles of hydrogen are you going to need? Well, since all the numbers are already up here, if you're going to make 2 moles of this, you're going to need 3 moles of that hydrogen. Alright? Now, the mole ratio, again, is simply using those coefficients. The 3 is in front of the hydrogen, so it's 3 moles of hydrogen will produce 2 moles of ammonia. And so if you put the mole ratio like so, the moles of ammonia will divide out with moles of ammonia, top and bottom. You're left with moles of hydrogen. And so now 2 times 3 is 6, divided by 2 is 3 moles of hydrogen. Now, all of that's fine and good. We're just playing around with the numbers that are already in the balanced equation. But most of the time, you're not going to be working with exact numbers of moles that line up with whatever's already in the balanced equation. So let's go ahead and try another one. What if I have 12 moles of hydrogen gas? All right. The question is, how many moles of ammonia am I going to produce? All right. Well, you're going to use the mole ratio. The mole ratio, again, you have a 2 in front of the ammonia, you have a 3 in front of the hydrogen, except this time, instead of having the 3 over the 2, we're going to put the 2 moles of ammonia on top, and we're going to put the 3 moles of hydrogen in the denominator, in the bottom. Now, why are we doing that? Well, because again, you want to get moles to divide out with moles. Moles of hydrogen on top divide out with moles of hydrogen on the bottom. You're left with moles of ammonia. You're looking for moles of ammonia, so you're all set to go. And so now perform the calculation. 12 times 2 is 24, divided by 3 is 8. So you're going to produce 8 moles of ammonia from 12 moles of hydrogen. All right. Let me change up colors here just so we can illustrate a few other points. What if I had 15 moles of hydrogen? Could I calculate the amount of nitrogen that I'm going to need in this case? So I want to know how many moles of nitrogen will I need to react with the 15 moles of hydrogen? Well, again, you're going to use the mole ratio. You're going to go out, look at the numbers out front. Now, if there's no number out in front, we assume that that's a 1. So you have a 1 and a 3. Now, is it going to be 1 over 3 or 3 over 1? Again, the units tell you. If you have moles of hydrogen on top here, you want your moles of hydrogen down here. The 3 goes with the moles of hydrogen. The 1 goes with the moles of nitrogen. It is a 1 to 3 ratio. The moles of hydrogen divide out top and bottom, and now perform the calculation. 15 times 1 is 15, divided by 3 is 5. So I would need 5 moles of nitrogen to react with the 15 moles of hydrogen. Okay? Now, those calculations are relatively easy to do in our head. Most of the time, you're not going to be working with numbers that round or divide evenly into one another. So, let's go ahead and try another one. Let's scroll down here. Let's just say, for example, let's change the colors here. Let's go with an orange this time. Let's just say we have 7.5 moles of nitrogen. How many moles of hydrogen will I need to react with the 7.5 moles of nitrogen? Well, again, the mole ratio in this case is the 3 to 1. You know that the 1 mole of nitrogen has to go on the bottom so that it can cancel out with that one. The 3 moles of hydrogen will go on top. Moles of N2 on the top, divide out with moles of N2 on the bottom. 7.5 times 3 divided by 1 is going to be 22.5 moles of hydrogen. All right. Let's just try a couple more here, just so we can drive home the point. Change this up. Let's go with a green here. We have, let's say, 2.98 moles of hydrogen. How many moles of ammonia could we produce from that? Well, the mole ratio, if you want to go from hydrogen to ammonia, is going to be a 2 to 3. This 2 over this 3. So 2 moles of ammonia will be produced from 3 moles of hydrogen. The moles of hydrogen divide out, top and bottom. 2.98 times 2 divided by 3 is going to be 1.99 moles of ammonia. Alright. And the last one. Let's change this up. Let's go with a lavender color. How's that? If we have 4.63 moles of ammonia that we want to produce, how many moles of nitrogen N2 would we need to produce that? Well, going back up to our reaction, nitrogen has a 1 out in front, the ammonia has a 2, so it's a 1 to 2 ratio. And again, how do you know which goes where? Well, the 1 mole of nitrogen needs to go on top because that's what we're trying to get into. The 2 moles of ammonia need to go in the denominator so that they can cancel out those moles of ammonia. And so now 4.63 times 1 divided by 2 is going to be 2.32 moles of nitrogen. All right. In the next podcast, we're going to give you an example where we have a few more species, and we'll be practicing the same types of calculations. We'll see you next time.